Hello everybody, welcome back. Today we're going to look at example 3 from section 6.2, slopes of parallel and perpendicular lines. So this is a continuation of the last video, and we're going to finish off section 6.2. So it says determine the slope of a line that is perpendicular to EF. So what you do here is you calculate the slope, and then once you have that slope, all you do is you take the negative reciprocal of that. Okay? So that's what we're going to do. So we're going to calculate the slope of EF, which is given by the change in y over the change in x, so y2 minus y1. So usually I pick the second value, so negative 1, subtract 3, and then the corresponding x value with the f, which was negative 4, subtract 2. Alright, so we subtract them, we get negative 4 sixths, which we might as well simplify. It's a rule of thumb for me is you simplify when you can. So you have negative 4, over negative 6, I apologize. That's just a little oversight there. We got negative over negative, which ends up being a positive, right? Because a negative divided by a negative is positive, and 4/6 simplified is 2/3. So that means that the slope of a line perpendicular to EF is a negative reciprocal of 2/3 of 2/3, which is negative 3 over 2, or negative 3/2. Okay? So we can answer the question. The slope of the line perpendicular to EF is negative 2/3. Okay? I'm doing double duty, but that's what the book did. I just want to be consistent. Alright? So the B part says determine the coordinates of G so that EG is perpendicular to the line EF. Okay. So first thing you do is draw the line EF. Once you have the line EF, then you can use the slope to pick another point on the line. So what we do is, the slope of the line EG is negative 3 over 2. So for each rise of negative 3 units, there's a run of 2 units. So what we do is, we go from point E, and from there, we use the perpendicular slope of negative 3 over 2. So from here we can go down 3, right 2, and get a point G. Another way you could have looked at it, you could have went the opposite way. So you could have looked at it as going left 2, up 3, and you still got another point G. Again, G will just depend on where you go from there. But most would go, like I normally do, is from there I'm always usually going right with the denominator, and if the numerator is negative, I go down. If it's positive, I go up. So it was negative 3 over 2, or 3/2. So that means I'm going to go down 3, right 2, and get my point G, which happens to be the x-intercept 4 and 0. You draw a line from E to G, connecting all the way through, and you can put a little square here, and this represents a 90-degree angle and shows that you have created a perpendicular line. There's an example question for you to work there on. Let's look at the final example for 6.2. It's using slope to identify a polygon. So in this question it says A, B, C, D is a parallelogram. Is it a rectangle? Justify your answer. So a parallelogram tells you that the lines A and B are parallel to D and C, and A and D are parallel to B and C. Well, in order to justify whether it's a rectangle, we know that the difference between a rectangle and a parallelogram is that the rectangles, their corners are 90-degree angles. So what we can do is we can find the slope of, well, for example, we could use AD and see if it's perpendicular to AB. So we don't have to do the justification on the AD to BC because it's already told us it's a parallelogram. So we know that opposite sides are indeed parallel. But what we don't know is, does it create a 90-degree angle? So in order to do that, you can find, and again, you could use anything here. You could use AD to compare it to AB, AB to BC, or whatever the case may be. So what I'm going to do is I'm going to compare AB to BC and see if they are perpendicular to one another. So the first thing we're going to do is we'll find slope AB. So what we'll do is we'll plug those values in. You could easily look at rise and run. I'm going to do the points again. Again, it doesn't make a difference. I mean, you can clearly see that it's going down for right 1, so we know it's -4. But what I will do is I'll do the formula just for practice. So we'll do the y value of b, which is -2, and the a value of y, which is the value is 2, and then the b value is of x value is -3, and minus a -4. So again, just looking at it, I determined it was -4, but this will just confirm that. -4 over, and this becomes -3 plus 4, add the opposite, which equals -4 over 1. Okay, I'm going to leave it like that. I'm not going to simplify it to -4, and you're going to see why in a minute. Next thing what we'll do is we'll find the slope of BC, and remember, if they are perpendicular, then we know that we have a rectangle, because a rectangle needs to have each corner of a rectangle needs to be 90 degrees. So we'll do the same thing with CB here. So CY value is 0. And we're going to minus the B value, which is -2, so minus a -2. Oh. And then we have the X value, which is 5 to the C, and the X value is -3, so minus a -3. Again, this is good practice. A lot of people will just take a look and see that we're going up 1, right 4, up 1, right 4, and indeed it is, but like I said, it's good practice. So this would be 0 plus 2 over 5 plus 3, which is equal to 2/8, which simplifies to 1/4. So they are indeed negative reciprocals of one another, so therefore they are perpendicular lines. Therefore, we do indeed have a rectangle. So since the slopes of AB and BC are negative reciprocals, A, B, and BC are perpendicular, that means that triangle ABC is a right angle, so ABC, and that means ABCD is indeed a rectangle because it is 90 degrees, a right angle. There's a check your understanding question that you guys can do the same thing. It's the exact same method. And then your homework questions will be page 394, 6, 8 through 11, 14, 16, and 18. And next we're going to be looking at, we're going to be using the graphing calculator and the math lab on 6.3 in the next video. So thanks everybody for watching. If you have any questions at all, please let me know. And thanks again. We'll see you in the next video.